Okay guys, so a circle of radius 1 is normal to a parabola y is equal to x squared. Now recall that two curves are normal to each other if the tangent lines at the point of intersection are, well, perpendicular to each other. And we're supposed to find the y coordinate of the center of the circle given that it actually lies on the y-axis. So how are we supposed to do it? Well, first of all, what kind of formulas describe those curves given in the plane? Well, we know that the parabola is given by y is equal to x squared from the problem statement. But what about the circle? Well, we know that its center lies on the y-axis, so it's going to be just and plain all x squared and then plus, well, y minus some kind of a k squared. Well, k is the amount by which we go downwards in this case with the center on the y-axis, and it's going to be equal to 1 squared, which is 1 because the radius of the circle is 1. Now if I were to isolate y from it, so I will make this entire expression a function of x, so I make y a function of x, I would get that y would be equal to 1 minus x, that is squared, under the square root, and then plus my k. This formula right here will actually nicely describe this part of the circle. It cannot really describe the lower part of the circle, because then for every single value of x I would have two values of y, so this wouldn't really be a function anymore. But it doesn't really matter, I don't really care about this this lower part, half, I want to say half, but it's definitely not half. This lower part of the circle, I don't really care about it because, as you can see, the parabola only intersects with the upper part of the circle. Awesome. So how are we supposed to get this k over here, this y coordinate of the center of the circle? You see, if I were to, if I managed to get my hands on the x coordinate, some x naught, which is the x coordinate of the point of intersection of those two curves, yeah, then I will be able to just kind of plug this x naught into my formula right over here, into my formula describing the circle, and then just set it equal to the square of this x naught, which is going to be the value of the function f of x equal to x squared right over here. And then I will get my k out of it. But how do I get the point of intersection? Well, I can get it because I know that those two curves are normal to each other. So at the points of intersection, the tangent lines to the curves at that point are perpendicular. So what does it mean for two lines in the coordinate system to be perpendicular? Let me say that I have, let's say I have two lines, y is equal to a1 times x plus some kind of a b1, not bi, but b1, and y is equal to some a2 times x plus a b2. So we know that should have said y1 and y2. Yeah, so y1 is perpendicular to y2 whenever the coefficients that are right here next to x's, so the slope coefficients of those lines, the quotient of those slope coefficients is -1. So we know that those lines, so I'm gonna draw the y1 and y2 lines here. This is y1 and this is y2 are perpendicular whenever a1 over a2 is equal to a -1. And this is exactly what we are gonna use here in this problem, because what are the slope coefficients of lines tangent to curves? Well, those are the derivatives of the formulas describing those curves at a given point. So let me use it. First of all, I am going to denote this x squared function as some kind of a f of x, just for consistency's sake, and this equation describing my circle, the upper half of the circle, upper part of the circle, as some g of x. I would like to calculate, well, what's gonna be easier? Well, definitely easier is going to be easier to calculate g prime of x divided by f prime of x, and we know that at the point of intersection, so at our x naught, this quotient is going to be equal to -1. And so now we can, well, go on and find our x0 basing on this information. Let's go and calculate those derivatives. G prime of x is going to be what? Well, that's going to be by the chain rule equal to -2x divided by 2 square roots of 1 minus x squared. The derivative of this k term is going to be just a 0. And now we will divide this entire fraction by the derivative of our function f, which is, well, just double the x, because this is a quadratic function and since everything is supposed to be a -1. However, you know that this double dx will just cancel out nicely with this negative double x here. I'm just gonna be left with a -1 in the numerator. So this thing will be equal to -1, but now just multiplying through by -1 and then by 2 square, maybe just the square root of 1 minus x squared, is going to give me that a half is equal to the square root of 1 minus x squared, and then it means that 1/4 and 1/4 is equal to 1 minus x squared, but it means that x0 squared, I should have said x0, and x0 squared is equal to 3/4. I also will put those arrows here so you know what comes from what. So we know that x0 squared is equal to 3/4. I'm not even calculating the x0, well, that's squared, because I'm not gonna really need it. And now let's go on and say, actually notice that at the point of intersection we have g of x0 be equal to f of x0. And so this means that at the point of intersection we will have 1 minus x0 squared plus the k we're looking for equal to x0 squared. But now let's just insert the value for x0 squared that we just found, which is 3/4, and we'll get a half here plus a k is equal to 3/4. That means that k is equal to 1/4, and so we know that the y-coordinate of the center of the circle is going to be 1/4, and the formula describing our circle is going to be x squared plus y minus a quarter, 1 minus a quarter, everything squared is equal to a 1, which is exactly what we were supposed to find. Hope you guys enjoyed it and see you in the next one. Bye.